In this video, we are going to start talking about linear programming problems. These types of problems are going to be very similar to what we just saw in the last video, where we were solving systems of inequalities by graphing. The only thing is these problems have an extra step. So just like before, we need to graph all of our inequalities onto the same graph and shade in the correct regions. So all of these inequalities are in y equals mx plus b, our slope-intercept form, where m is our slope and b is our y-intercept. So for the first one, y is greater than or equal to negative x minus 2. Our y-intercept is negative 2, so we have to go down 2 from the origin. And we have to apply the slope of negative 1. So that means we have to go to the left 1, up 1, to the left 1, up 1, to the left 1, up 1, and so on, till we get enough points. And we are going to connect these points with a solid line because we have the inequality greater than or equal to. And when we are going to shade in, we have to shade in above this line that we drew because greater than means anything bigger. So for our next inequality, we have y is greater than or equal to 3x plus 2. So again, our y-intercept, we have to graph that point first, is going to be at positive 2. And we have to apply the slope of positive 3. So rise over run means we have to go up 3, 1, 2, 3, over 1. And since I can't keep going in this direction because I don't have enough, I'm just going to go down, so 1, 2, 3, and left 1. And I'm going to connect these points again with a solid line because our inequality is greater than or equal to. And this time, since we have the greater than or equal to sign, greater than or equal to is going to be anything above the line that we drew. So I'm going to shade in that region. This time, we have 3 inequalities, so we still have one more to go. Y is less than or equal to x plus 4. So our y-intercept this time is going to be a positive 4. Oops, 2, 3, 4, right here. And we have to apply a slope of positive 1. So we are going to go up 1 over 1, up 1 over 1, and so on. And again, we are going to connect it with a solid line because we have less than or equal to. And so when we are going to be shading, since we have a less than or equal to, well, you guessed it, we have to graph or shade in anything below that line we drew. So right now, our entire graph is covered in colors, but the only part that we are worried about is where all 3 of those overlap. So we are looking at this triangle right over here. And so I just want to label all of the points that I have. So I'll start with A, B, and C. And so let's find the coordinates of those points to help us solve the rest of the problem. So point A is at positive 1 for our x and 1, 2, 3, 4, 5 for our y. What about point B? Well, we had to go to the left 1, so negative 1 for our x, and then we had to go down 1, so negative 1 for our y. And finally, point C, we had to go 1, 2, 3 to the left, so we have negative 3, and we had to go up 1, so positive 1 for our y. In linear programming problems, we are always given this funky equation where we have to plug in an x and a y. So this is where the points A, B, and C that we found come into play. So we want to take each and every single one of these points and plug them into the equation and see what number we're going to get out. we are either going to be trying to maximize this function or we are going to minimize it. So if we are going to try and maximize, we need to try and find the biggest number. And if we are trying to minimize the function, we need to find the smallest number. So let's go ahead and try plugging in point A. So my equation started with -3. My x value was a 1. Then we add 5 multiplied by our y, which was 5. And so -3 times 1 is -3, plus 5 times 5, which is 25. And we get out a positive 22. All right, so this one was for point A. I'm just going to write that off to the side here. For point B, if we plug that one in, I'll just break this up. We had a -3 for our equation multiplied by a -1 plus 5 multiplied by our y, which was also -1. And so what we get out, -3 times -1 gives us a positive 3, plus 5 times -1 is a -5. So 3 plus a -5 is the same thing as 3 minus 5. So we get out a -2. So this was for point B. Finally, for point C, I don't have enough room on that side, so I'm going to move over here. I need to plug in a -3 for x. So I had -3 multiplied by -3 plus 5 multiplied by our y, which was positive 1. So -3 times -3 gives us a positive 9, plus 5 times 1 is 5. 9 plus 5 is 14. So for C, we got out 14. If we wanted to maximize our function, we need to look for the biggest number that we got out. So out of all these 22, -2, and 14, 22 is the biggest. So point A would maximize our function. If we wanted to minimize the function, we have to look for the smallest numbers. So -2 is our smallest number, so point B would minimize our function.